Hello, welcome to our channel for rprogramming. In this video, we will talk about test of linearity of regression model with R. So we know if we want to know if in a linear regression only the first power of independent variables in the model. So we have to test this assumption. This is called linearity assumption. And if there is some second power or third power or multiplication of independent variables exists in the model, but we have omitted this item. So this is called the lack of fit, and it means the model is not appropriate. So we have to test this assumption and usually use a so-called component-plus-residual plots. So what this means? The left term is residue, EI. Residue is the difference between observations of Y and the model fit the value of Y. So this is residue. And beta k times xik, though this is one of the beta coefficient estimated times one of the x variables. And this combination will plot it against x variable. So because this item is actually the combination of the beta and xi, so this will be a straight line, right? But the error term plus this will be added randomness, so the plot will show both the straight line and the smoothed line combined with the error term. So next we will show how to implement this in R. The car package in R provides a function called crPlots. Will do this job. So next we go to RStudio. So first we have to load library car. Then we create a data frame called states. And the states has 5 columns. And these variables comes from a data frame called state x77. This is included in R-based framework. So we can see this data frame contains the demographic variables for 50 states in USA for the murder, population, illiteracy, income, and frost. So say we want to estimate a linear regression model of murder rate against the population, illiteracy, income, and frost. And in the model, we only include first power of independent variables. Then we just run this linear regression model using LM function. So the result of this estimation of the linear regression model will be assigned to a variable to object called fit. Then we can use crPlots fit. So this is done, and the result is quite clear. There are 4 subplots, each represents one x variables. So population, literacy, income, and frost. And the y, or the vertical variable, is the combination of component plus residual. And component is beta coefficient for this variable and times this variable. So actually this dashed line is a straight line, is exact straight line. And this colored line is a smooth line, or say Lewis line, including the random item representing the residues from the model. So if the model is appropriate, or say only linear items, only first power items in the model, So this fitted or smooth line will be exactly the same as this dashed line. So if there is a systematic pattern showing of this orange line very far from this straight line, so it means there are some higher power of the items missed, omitted in the module. So in this case, say all these three are very consistent between the Lewis line, smooth line, and the dashed line. And only this one has a little far from between these two lines in the higher value of the x variable. But if we see this point, it means maybe a very special point or outliers. But overall, the model shows it is quite correct that we only use the linear items in the module. Thanks for watching.